Hey guys, in this video we're going to take a look at how we find real zeros of a function. If you set a function equal to 0 and solve for x, you will get the zeros of that function. Now this may sound a little familiar to you because we've done this exact same thing before when a problem has asked for us to find a solution or find an x-intercept. Okay, this is the same thing as plugging 0 into y and solving for x, which is how you find x-intercepts. Now, if it's in function notation, your y will actually look like f of x. Okay, so what you would be doing is replacing all of f of x with 0. Okay, plug 0 in, put 0 on one side of the function, ever how you want to think of it, so that the real zeros of a function are the x-intercepts of the function. It's the same thing, okay? So when you find real zeros, you are finding the x-intercepts of that particular function, okay? One thing to note, imaginary zeros will not be x-intercepts. That's because in the graphing that we're doing in this class, we don't graph imaginary numbers. They're not in our coordinate system. We only have real numbers in our coordinate system. So when you're talking about x-intercepts, okay, or real zeros, any imaginary numbers that you might get while you're solving for x, you will just need to throw away, okay? We won't need them here. When we're doing solutions, or if we're finding all zeros, we will keep them. But for what we're doing right now, we're sort of looking at the connection between the real zeros and the x-intercepts. So any imaginary zeros that you might get in any homework problems, you just won't use, okay? All right, let's move on and let's take a look at an example, okay? We're going to find the real zeros of this little polynomial that I've given you, polynomial function. It's a quadratic. F of x is equal to x squared minus 2x plus 3. We will need to factor this. So what we're going to do first, of course, is set it equal to 0. So where I've got f of x, I'm going to put a 0. You can use the quadratic formula on this if you would rather, but it's good if you can do the factoring, okay? It's going to help you throughout the stuff on this test if you can make the connection between the factors and the zeros. So what we're doing here is we're going to factor this and set each factor equal to 0, just like we would if we were solving a quadratic normally. So 2 factors of -3, that will give you that -2 when they're subtracted. That's going to be a -3 and a +1. Take each one, set it equal to 0, and this will finish you out here, okay? So we get x is equal to 3 and x is equal to -1. Those are our two zeros, okay? They're both real, so we keep both of them. And those are our real zeros for this polynomial. Now I want to show you something kind of neat. Let's look at the graph of f of x and compare it to the zeros that we just found. I'll pull it down here where we can see it. Whoops. Sorry, I accidentally stuck those together. Let me, hang on a second. Okay, I think I finally got it pulled. Well, now it's still stuck to it. Dadgummit. Alright, hang on a second. Let me see if I can... Okay, now I've got it where I can pull it. Alright, here's the graph that I was trying to show you. Let me expand it just a little bit here. Alright, this is the graph of that same polynomial. And what we're looking at here are the two x-intercepts. I want you to notice that we do have one at x equals 3 right here, and then we have another one at x equals -1. So like I said, the real zeros are the same thing as your x-intercepts. You find them the exact same way. So you're not really learning anything new other than new terminology, okay? You're learning that when it says find the real zeros, you do the same thing you would do if you were just looking for the x-intercepts.